The prisoner's dilemma is a thought experiment that challenges two rational agents to a dilemma. They can cooperate with their partner for mutual benefit or betray their partner for individual reward. The classic version of the prisoner's dilemma goes like this. Two guilty criminals are arrested and imprisoned. Each prisoner is in solitary confinement and cannot communicate with their partner. The crime they're both guilty of comes with a sentence of 5 years in prison, but the police do not have enough evidence to successfully convict them of it. They do have enough evidence to convict them of a crime with a lesser sentence of 1 year in prison. In order to try and get the prisoners to confess to a more severe crime, the police offer each of the prisoners a deal. Confess, and we will reduce your sentence. What should these prisoners do? Is the rational thing to do to confess or stay silent? Game theory is the application of mathematical models to strategic interaction among rational decision makers. In order to analyze and predict what each prisoner will do, we want to formalize their dilemma into a payoff matrix. This shows us every possible outcome for the prisoner's dilemma. If prisoner A chooses to cooperate, meaning they will stay quiet, and prisoner B also chooses to cooperate, they will each be convicted of the lesser crime only and will face 1 year in prison each. In this chart, the orange text tells us the outcome for prisoner A, and the green text tells us the outcome for prisoner B. If prisoner A decides to confess, but prisoner B cooperates, then prisoner A will get special treatment from the prosecutors. Prisoner A will serve 0 years in prison, while prisoner B is sentenced to 5 years. Conversely, if prisoner A chooses to cooperate, but prisoner B chooses to confess, then prisoner A will get 5 years in prison, while prisoner B gets 0 years. And lastly, if prisoner A chooses to confess and prisoner B also chooses to confess, then in that situation, both get charged with the more severe crime, but their sentences are reduced due to their cooperation, with each of them serving 3 years in prison. This is how game theorists like to break down a game. A game consists of players, like prisoner A and prisoner B, strategies, like cooperate and confess, and a payoff matrix, which shows the payoff for each player in each possible outcome. Visualizing a game in this way helps us to see what a rational decision maker is going to do. Rational decision makers attempt to optimize their own outcome, and so each prisoner will seek the best possible payoff for themselves. And that is where the prisoner's dilemma gets interesting. One critical assumption we'll make with games is that they are non-cooperative, which just means that the players are not able to coordinate with each other to try and agree on a certain outcome. Each player has to make their choice in isolation of the other players. One thing we want to look for in any game is a dominant strategy. A dominant strategy is a strategy that is better for a player no matter what strategy their opponent chooses. Let's look at player B to see if they have a dominant strategy. Player B has the option of choosing cooperate or choosing confess. If they choose cooperate, then they're either going to get 1 year in prison or 5 years in prison, depending on what player A does. If they choose confess, then they're either going to get 0 years in prison or 3 years in prison. This one is player B's dominant strategy. If player A chooses cooperate, then player B gets 0 years in prison, which is better than getting the 1 year they would end up with had they cooperated instead. If player A chooses confess, then player B gets 3 years in prison, which is better than getting 5 years in prison, which is what they would end up with had they cooperated instead. In other words, no matter what player A does, player B will wish they had confessed, because their payoff will always be better in that scenario than if they had cooperated. Of course, the same is true for player A, who has a dominant strategy of confess, which means that if both players are rational decision makers, they will both choose to confess, meaning we end up with this outcome where each player gets 3 years in prison. What's curious about this is that both players would prefer 1 year in prison over 3 years in prison. This is a surprising outcome because it's at odds with our main conclusion of the course so far, which is that when people do follow their self-interest, they will end up doing the thing that benefits society the most. When the baker follows their self-interest of wanting to get paid, they end up feeding the town, which is good for everyone involved. But here is an example where following self-interest leads to an outcome which definitely isn't good for everyone involved. The two prisoners would both be better off if they had just stayed quiet. Taken at face value, the prisoner's dilemma explains the logic of a classic interrogation technique used by the police to try and get people to confess to crimes. And if these prisoners really are guilty, then probably getting both of them to confess is what's best for society. But as a thought experiment, it blasts a hole into economic theory, showing us instances where a lack of cooperation can lead to suboptimal outcomes. And that is something we're going to want to explore.